Hey guys, Mr. Milton here. Today we're going to look at similarity in right triangles. Okay, at the end of this video, you should be able to simplify radicals and use the skill with Pythagorean theorem. You should also be able to explain what the geometric mean is and find the geometric mean of two numbers. And you should be able to separate a right triangle into three similar right triangles and match up their corresponding parts. Okay, so let's start. This first part is review, should be review from algebra, and that is simplifying radicals. Okay, so here they're asking us to simplify a radical, or tell us the answer of radical 147. Tell us the answer. Simplify radical 147, right? That is a simplify radical. And so remember that to do that, we basically make a number tree, one way to do it, and just find numbers that multiply to give us 147. Only rule is we can't use the number 1 as a multiplication. And so once we get stuck where we can't do any more multiplication without using number 1, then we're done. Okay, so we have 147. I know that 7 goes in there, and that's 2, 1. 7 times 21. Okay, now I know that 7 is a prime number, so I'm not going to be able to multiply anything else but 1. So I'm going to circle that number, know that that branch of the tree is dead, and then continue with 21. What multiplies give me 21? 7 and 3. So prime, prime. Okay, so now I'm all done, all prime numbers. And now this big multiplication problem, 7 times 3, will multiply to give me 147. What I'm going to do is I'm going to take my pair out. If I have a pair of numbers, they go on the outside. The one without a pair stays inside. So radical 147 is a simplified radical is 7 radical 3. Okay. Next problem, 320. Okay, so a couple ways that we can break this down. And remember, you can break this down however you'd like to, as long as it multiplies to 320 at the end, works great. Okay, so what I've noticed here is that, hey, I got 32 times 10. I could do this a little bit easier and say, hey, 64 times 5. 5's prime. And then I chose 64 on purpose. 64 is a perfect square. Okay, remember, I'm looking for pairs here. And so if I can find a perfect square, or the largest perfect square, it cuts my length of my problem down, right? 8 times 8 is 64. Now I could continue to break this down and get a bunch of 2's, but I did this on purpose because I have a pair of 8's. And as we saw in the last problem, all I'm really looking for is a pair to take out of my radical. And so now I've made this into a multiplication problem, 8 times 8 times 5, and I'm taking my pair of 8's out. 8 and my 5 doesn't have a pair. Radical 5. Okay, just to show you how this could be different if you chose different numbers, do this in purple here. If we did 320, okay, and I said, okay, 2 times 160. Then I said 16 times 10, 2's prime, I'm going to circle that. 5 times 2 gives me 10, circle that. I'm going to do 2 times 8, 4 times 2, 2 times 2. Okay, so first of all, you see how much larger this tree is that I use these numbers. So picking numbers, if you can see the larger of the perfect squares, makes it a little bit easier. But if you can't, and you just use 2 and the smallest ones you can think of, that works as well. Okay, so now look, as I go through and I make my radical, I have 1, 2, 3, 4, 5, 6 2's that I need to bring in there. And a 5. Okay, and now when I take out my pairs, I have 1, 2, 3 2's that I need to bring outside, and a 5 without a pair. So it would be 2 times 2 times 2 outside, and a 5 that's still inside. 2 times 2 is 4, times 2 is 8. So no matter how I do this, simplify is going to give me 8 radical 5. You do not need to do that multiple ways. Just wanted to show you how that works. All right, and then finally we have number 3, 2 radical 6 squared. Okay, very important that we don't try to jump to finding a shortcut. Squared just means multiplied by itself. And so I always just advise that you say, okay, well, that means I'm going to multiply 2 radical 6 times 2 radical 6. Remember, for our radicals, we have a couple operation rules, and one of those is that multiplication, you multiply outside numbers together, you multiply inside numbers together. That's it. Outside times outside, inside times inside. So 2 times 2, both on the outside, multiply together, give us 4. Radical 6 times radical 6, both on the inside, multiply together, give us radical 36. Radical 36, 36 is a perfect square. So radical 36 is 6. I can rewrite that as just 6. 4 times 6, and that is 24. Okay. All right, so hopefully I'll review there and how to do that. It's going to be important for us as we go through the Pythagorean theorem. Okay, it says find the missing side of the right triangle using Pythagorean's theorem. Leave your answer in the simplest radical form. Remember Pythagorean's theorem says a squared plus b squared equals c squared. Okay, where a and b are the legs and c is the hypotenuse. Okay, and so in our first triangle we have a leg 8, a leg 12, should equal this unknown, I'm just going to call it c squared. So 8 squared 64, 12 squared is 144, equals c squared. That gives us 208. Okay, and then it said you write your answer in the simplest radical form. So in order to find out what c is, I need to take the square root of both these. Square root of 208. I'll do my thing here. Is that 4 and 52? Looks like 13 and 4. All right, 13's prime. I could break these 4's down, but again, I see I have a pair of 4's. Okay, and so I have 4 times 13. Take out my pair. 4 radical 13. If you came to some other way to get to this, that's fine. You should have ended up with 4 radical 13 for your length of that hypotenuse. All right, next example, we have, we're trying to find this side S. Now, you should notice that, hey, we're given the hypotenuse here of 2 radical 21. So when we set this up, we'll still do a squared plus b squared equals c squared. A squared plus b squared equals c squared. But notice here that our unknown is on the left side, not on the right. Okay, so 6 squared, 36. 2 times 2 is 4. Radical 21 times radical 21 give us 21, right? If you multiply a radical by itself, the radical sign will go away. You'll notice that that is what happened in our last problem as well, right? Radical 6 times radical 6 gave us 6. The radical sign went away. Okay, so we have 4 times 21 or 84. And that is what should happen anytime we square a square root. There shouldn't be a square root left. All right, so now we are trying to find s squared. I'm going to subtract 36 from both sides. That gives me 48. So s squared equals 48. To find s, I'm going to take the square root. 16 times 3. 3 is prime. 4 and 4. And I have a pair of 4s. A pair of 4s and a 3 without a pair. 4 radical 3. So, new stuff. Geometric mean of two numbers is the average of the two numbers after you multiply them. Okay, to find the geometric mean, you need to set up a proportion. Okay, so here, the definition might be funky, but the proportion isn't. When we want to find the geometric mean between two numbers, we set up this proportion. Two numbers, we'll set up those two numbers, 2 and 50, like this, and the geometric mean is going to be the number that makes this proportion true. Okay, in the textbook it says something like the geometric mean is the number that makes, if we have a and b, the number x that makes the proportion true. Okay, and so that's what we're doing. Cross multiplying, 2 times 50 gives us 100. G times g gives us g squared. Take the square root. We find that g is, and remember we're taking the square root, we want to say plus or minus 10. It's a positive or negative. Okay. The only time, again, that we wouldn't want to say plus or minus is if we're actually given a length, because remember we can't have negative lengths, but we can't have negative numbers, so we don't want to exclude that possibility here. Next one says find the geometric mean between 5 and 15. So we'll set it up as 5, 15, and then the value that makes that proportion true. So 5 times 15 gives us 75 equals x squared. Take the square root. That's 25 and 3. 3 prime. 5 and 5. Pair of 5s. And so x would equal positive or negative, plus or minus 5 radical 3. All right, now here's the important part. I know that everything's important, but here's what we're trying to build up to. Finding the similarity in right triangles. There are a couple methods that we'll talk about, but here is the first method. And this method is called redraw and label. Okay, and so what we'll do here is that we're going to look, we see this right triangle, right, with the line drawn here from our 90-degree angle perpendicular to the other side. Okay, and so what we're going to do is we look at this line, and we're going to notice that what it does is it separates this triangle and creates two more similar triangles, or two more triangles that are similar to the original triangle. Okay, and here's how we can see that. This left triangle, okay, we have this side R, we have the hypotenuse of this left triangle A, and you'll notice that since this angle is 90 degrees, this angle should be 90 degrees as well, H. Okay, and our medium triangle, I'm talking about this side, okay, we already have this angle 90 drawn for us. This is H, this is B, this is S. And then in our large triangle, we have this side C, this side B, and this side A, and that this is 90 degrees. All right. So, let's talk about this. It says each side has three sides, short leg, a long leg, and a hypotenuse. Label each of those in the triangle. So as we look, use a different color, it's pretty easy to label the hypotenuse, right? The hypotenuse is always across from the right angle. So here's my hypotenuse. B is my hypotenuse here. C is my hypotenuse here. That's the easy one to label because there, it's easy to see. Okay, visually here, it might be a little bit easier to label the short side. Let's call that short, right? A seems the shorter side of the larger triangle. H is the shorter side of the medium triangle. And R is the short side of the smaller triangle. Okay, and then H is a long leg, long leg, long leg. Okay. Now, what I want to point out before we go too far is that these triangles are all similar to each other. And we're going to be able to prove that with angle-angle similarity. And a little bit more in depth, we're going to be able to prove it using the reflexive property. Okay, what you'll notice is that each of these triangles shares an angle with our large triangle that never gets touched. Okay, so if we look at our small triangle, you'll notice that this angle here is the same, like the exact same as this angle here, okay, by the reflexive property. And so between our small and our large triangle, we know that they are similar because of angle-angle similarity. Okay, as we look at our medium triangle, you'll notice that this angle here, two arcs, is the same as this angle here. Again, it doesn't get touched. And so both right triangles both have this angle-angle similarity, which tells us that our medium is congruent to our large. So since our small is congruent to since our medium is congruent to our medium is similar to our large. Since our small triangle is similar to our large triangle, and our medium triangle is similar to our large triangle, then our small triangle has to be similar to our medium triangle. They're all similar together. From there then, we have three similar triangles just with this altitude drawn from the right angle. It says now, using your redrawn triangles, find the missing side in each proportion. So here's how we'll do this. We labeled our sides short, long, and hypotenuse, short, long, and hypotenuse, short, long, and hypotenuse. Okay, we've talked about these being similar triangles, and so now we're going to use that information in order to finish these missing pieces of our proportion. R over H. What I'm going to do is I'm going to realize or notice which triangle that's in. That's in our small triangle, R and H. R is our short leg, H is our long leg. And so I'm going to look for the triangle that has S as its long leg. That's our medium triangle, has S as its long leg. And then I need to find the short leg in it. The short leg in that triangle is H. So for number 1, H is our missing side for the proportion. Okay. Number 2, I'm given R and A. R is our short, A is our hypotenuse in the small triangle. So I'm going to set that up as short over hypotenuse. Okay, so short R, A. Okay, and now I'm looking for the triangle that has A as its short leg. And that's in the large triangle. In the large triangle, A is its short leg, and I'm looking for the hypotenuse in that triangle, and that's C. So my missing side here would be C. Number 3, they flipped the order around on me, but I have my complete proportion, or my complete ratio here, B and C. Which triangles B and C in my large triangle? And that is my long side and my hypotenuse. So I'm looking for the triangle where S is my long side, and that's the medium. And the hypotenuse in that triangle is B. And number 4, I have B and H. B and H are in our medium triangle, and that's hypotenuse and short. Hypotenuse, short. Okay, so I'm looking for the triangle where A is my hypotenuse. That's my small triangle. My short side is R. And so by drawing and labeling out these triangles, I was able to finish these proportions just by recognizing what sides they were. All right, so let's do that again here. It says separate, redraw, and label the triangles, then set up proportions to solve the variables. So here's what we have to do. We're given this triangle with the altitude from the hypotenuse, or from the right angle, and so we're going to redraw these. Okay, and so on my left side I have X, Y, 4. This is my 90-degree angle. Okay, my medium one here. Okay, I have Y here, 5 here. I don't know. Okay, and then I'm just going to redraw this large one as well, 4 and 5. So I'm going to call this 9X. As I look here, I need to label these sides. X is my hypotenuse. This is my hypotenuse. I don't have it. This is my hypotenuse. Okay, in this triangle, X appears to be my short side. Y is my short side. 4 is my short side. And now I have this as my long, long, long. Okay, so here, I'm trying to find X. And so what I'm going to do is I'm going to try to use the triangles where X is visible. Okay, and that is my first triangle and my last triangle. Okay, I'll notice that in this triangles, X is the hypotenuse and the short. So that's kind of a clue that, hey, I'm probably going to have to use hypotenuse over short, or short over hypotenuse, however you want to use that. Okay, so in this triangle, I have hypotenuse of X and short of 4. In this triangle, I have hypotenuse of 9 and short of X. And so I can cross multiply and find that X squared equals 36. Take the square root, and I should get 6 and negative 6. But remember that since we're talking about actual side lengths, then I will not include the negative side length. So X is 6. Okay, and now I want to find Y. And again, I'm going to use the triangles where Y is visible. So here, Y is the short, and this side is the long. So I'm probably going to use the short and long side. Short over long. So in this triangle, short is 4, long is Y. In this triangle, short is Y, long is 5. Okay, now I have my proportion. I can solve it. 20 equals Y squared. Take the square root. That's 4 and 5. 2 and 2. And so I can find that y is 2 radical 5. Again, I will not include the negative here because it's the actual length. All right, and so now that's using um, similarity in these right triangles to solve for missing pieces. All right, see ya.